To connect to Upstash Redis, the "upstash-vector-store" needs credentials such as an API key or a Redis URL. Think of it like needing a key to unlock a door to access data. Without valid credentials, it can't access the database. The "upstash-vector-store" has the function of enabling the similarity searches. This means finding the documents in the Upstash Redis database that are most similar to the search query, enabling retrieval of relevant results. The UpstashVectorStore is designed specifically for the Upstash Redis serverless offering. This means that it is optimized to align with the characteristics and features of Upstash Redis that can result in better performance and ease of use. Let's delve into "upstash-vector-store". This is a class within the langchain_community library, specifically designed for interacting with Upstash's Redis database as a vector store. Think of it as a bridge, allowing you to store and retrieve vector embeddings efficiently using Upstash's services. You'll need an Upstash account and valid credentials, like an API key, to use the UpstashVectorStore. These credentials act as your username and password, ensuring only authorized users can access and modify the data stored in your Upstash Redis instance. Without these, the store won't be able to connect to your database. To repeat, the UpstashVectorStore requires either a Redis API key or a Redis URL. The API key is specific to Upstash, while the Redis URL is a standard connection string used to connect to Redis databases. Both serve the same purpose, authenticating your application with the Upstash Redis service. The UpstashVectorStore uses Upstash's Redis database to store vector embeddings. Redis, in general, is an in-memory data store known for its speed and efficiency. Upstash provides a serverless Redis offering, making it easy to use Redis without managing servers. The UpstashVectorStore is where vector embeddings are stored. But wait, what are vector embeddings? They are numerical representations of text or other data, capturing their semantic meaning. These embeddings allow you to perform similarity searches, finding documents with similar meanings. One of the main purposes is to provide similarity search functionality. It efficiently finds documents that are semantically similar to a query by comparing vector embeddings. This is useful for tasks like information retrieval and recommendation systems. To repeat, the vector store helps retrieve similar documents. The efficiency of this retrieval depends on the indexing techniques used. Hence lib can be used optimized specifically for Redis data structures. The UpstashVectorStore is optimized to work seamlessly with Upstash's Redis service. This means it takes advantage of Upstash Redis's specific features and capabilities for efficient storage and retrieval of vector embeddings. The UpstashVectorStore is also optimized for Upstash's serverless architecture and data storage capabilities. Serverless means you don't have to manage servers. Upstash handles the infrastructure, allowing you to focus on your application. Now, let's delve into the architecture and operations of the UpstashVectorStore. Think of it as a specialized tool optimized for storing and retrieving vector embeddings within the Upstash Redis environment. It manages the interaction between LangChain and Upstash Redis, handling data storage and retrieval in a way that's tailored to Upstash's serverless architecture. This involves using specific data structures and indexing techniques optimized for Redis. Now, let's talk about how the UpstashVectorStore fits into a larger LangChain application. The LangChain application is the overall system that uses the vector store for tasks like question answering, document retrieval, or semantic search. The UpstashVectorStore acts as a component within this application, providing the functionality to store and search embeddings. The vector store enhances the application's ability to work with text data. The embedding model is a crucial part of the process that transforms text into numerical vector embeddings. An example of an embedding model is OpenAI embeddings. These models use machine learning to capture the semantic meaning of text. The resulting embeddings are then stored in the UpstashVectorStore for similarity searches. Now, let's discuss the initial stage. The process begins with documents, which represent the raw text data that will be processed. These documents can be anything from paragraphs to entire books, and they are the foundation upon which the vector store is built. Now, let's generate embeddings. This stage involves using an embedding model to convert the documents into vector embeddings. This process transforms the text data into numerical representations that capture the semantic meaning of the text. Now, let's store embeddings. The generated embeddings are stored in the UpstashVectorStore, which utilizes Upstash Redis to efficiently manage and index these vectors. This storage process involves organizing the embeddings in a way that allows for fast and accurate similarity searches. Now, let's search for similarity. This is a core function of the vector store. Given a query, the UpstashVectorStore finds the most similar documents by comparing the embedding of the query to the embeddings of the stored documents. Now, let's discuss the query. A query is a piece of text for which relevant documents are to be found. The query text is also converted into a vector embedding, which is then used to compare against the stored document embeddings. Now, let's focus on relevant documents. The ultimate result of a similarity search is a set of documents that are deemed most relevant to the query. These documents are ranked based on their similarity scores, providing a way to retrieve information that is semantically related to the query. Now, let's discuss Upstash Redis. This is the underlying database used by the UpstashVectorStore to store and manage vector embeddings. Upstash Redis offers a serverless and scalable environment for working with data, making it well-suited for vector storage and similarity searches. Now, let's get into the specifics of the UpstashVectorStore. The UpstashVectorStore is a specialized component designed for efficiently storing and retrieving vector embeddings within the Upstash environment. It acts as an interface between a LangChain application and an Upstash Redis database, providing methods for adding vectors, performing similarity searches, and managing the stored embeddings. The UpstashVectorStore is a class within the langchaincommunity library. It's designed to facilitate interaction with the Upstash Redis database. It allows for storing and retrieving vector embeddings, which are numerical representations of data used in machine learning for tasks like similarity search. Upstash Redis is a serverless Redis database service. It's offered by Upstash and is designed for low-latency data access and scalability. The UpstashVectorStore is built to work seamlessly with Upstash Redis. Vector embeddings are numerical representations of data, often text or images, in a high-dimensional space. These embeddings capture the semantic meaning of the data, allowing for efficient similarity comparisons. For example, words with similar meanings will have vector embeddings that are close to each other in the vector space. An embedding model is a machine learning model that converts input data, such as text or images, into vector embeddings. These models are trained to capture the semantic meaning of the data, so that similar inputs have similar embeddings. Examples include OpenAI embeddings and Hugging Face embeddings. Similarity search, also known as nearest neighbor search, is the process of finding data points that are most similar to a given query point. In the context of vector embeddings, this involves comparing the vector embedding of the query with the embeddings of the data points stored in a vector database like Upstash Redis. The UpstashVectorStore is specifically designed to work with Upstash Redis. This means it's optimized for Upstash Redis's unique features and architecture, like its serverless nature. This specialization can lead to better performance and efficiency when using Upstash Redis as a vector database. It finds semantically similar data by using vector embeddings. The UpstashVectorStore facilitates similarity searches within the Upstash Redis database. It's optimized for the characteristics and features of Upstash Redis, leading to efficient management and similarity searches within that environment. Text data is the raw textual content that you want to analyze and search. It can be documents, articles, or any other form of written information. To use text data with a vector store, you first need to convert it into vector embeddings using an embedding model. Alright, let's talk about documents. In the context of this vector store, these are the raw text you want to analyze and search. They could be anything from product descriptions to research papers. This converts your text documents into numerical vector representations. The example given, OpenAI embeddings, is just one option. Others exist, each with different strengths and trade-offs in terms of speed, cost, and accuracy. These are the numerical representations of your documents generated by the embedding model. Each vector captures the semantic meaning of its corresponding document, allowing for similarity comparisons. This is the serverless Redis database provided by Upstash. It's where the vector embeddings are stored and indexed for efficient retrieval during similarity searches. This is the text input used to search for similar documents in the vector store. The query also needs to be converted into a vector embedding using the same embedding model used for the documents. Now, this is where the magic happens. This process compares the query's vector embedding to the vector embeddings of all the documents in the UpStash Redis database. Distance metrics, like cosine similarity, are used to rank the documents based on their similarity to the query. These are the documents that the similarity search identifies as being the most semantically similar to the query. They are the results of your search. This refers to a larger application built using the LangChain framework, where the UpstashVectorStore might be just one component within a chain or sequence of operations. This could be a chatbot, a document summarization tool, or any other application that needs to process and understand text data. How exciting! It is the step where raw text documents are transformed into numerical vector embeddings. As was covered, the embedding model is critical during this step. This represents the communication between different components in your LangChain application. For instance, it covers communication between your application and the UpstashVectorStore when you're adding documents or performing similarity searches. Oh my goodness! The UpstashVectorStore acts as a bridge between LangChain applications and the Upstash Redis database for storing and searching vector embeddings. It handles the details of interacting with Redis, allowing developers to focus on the higher-level logic of their applications. Wonderful! These are operations applied to your documents before or after they interact with the vector store. Examples include splitting large documents into smaller chunks or cleaning the text to remove irrelevant information. Let's explore LangChain application. It acts as a wrapper. It allows developers to build end-to-end applications using large language models.